So in the previous few classes, we looked at operators and operator precedence, right? Today we will start with the next topic, that is if-else statements, and tomorrow we will look at switch statements. So basically decision-making statements, we will look at them today. The right side one, you already know. What is it called? Right side one? It's called a flowchart, right? So this flowchart, it is also considered as pseudocode. So we will see what a pseudocode is in a minute. So pseudocode can be written in different ways. Yeah, I need pin drop silence. If you're not interested, please leave. Okay, last two, that boy and girl, get out. Quickly. Leave immediately, please. So pseudocode can be written in different ways. It can be written in plain English, any spoken language, or it can be written in a slightly formal and informal in a midway. Like so, this flowchart is one such way. I will show you another way in which we can write the pseudocode. So, say for instance, so what is the previous code saying? It's just saying take two numbers as input, add them, and print the sum. All right. This same thing can also be written as read two numbers n1 and n2, and add them and store the value in a variable called sum, and finally print sum. Okay. So this is one way of writing the pseudocode. This is not exact code, because exact code will require all the syntax, the punctuation marks, the brackets, semicolons, everything. We just want to not worry about those things and just focus on the logic. So when you capture basically this is an algorithm, right? Flowchart is discussing an algorithm. So that algorithm you express in various ways. You can explain that algorithm in a paragraph in plain English. That is one way of describing the algorithm. Another way is you actually capture that entire algorithm in your code. So these are two extremes. One is completely plain natural language. Another is completely formal programming language. In between, we have pseudocode. So pseudocode, like this form, this example which you're seeing, it is convenient for both coders and non-coders. For coders, it is easy to translate this pseudocode into code. For non-coders, it is easy to understand what your code is going to do. Okay, what your algorithm is. So that's the idea of a pseudocode. Fine. And you also know the symbols in a flowchart, right? Like oval symbol, it represents start or end. Like in this flowchart, if you see start and end, they have oval symbols. And parallelogram, sorry, before that, arrows are basically connectors. They connect different boxes, different symbols in the flowchart. Parallelogram indicates input or output. So if you look at this flowchart, input, that is scanning two numbers, that is in parallelogram. Similarly, printing the sum, that is output, that is also in parallelogram. So if you're taking an input or you're printing an output, both of them should be represented in parallelogram. And this rectangle basically refers to some processing. Whatever processing you're doing, it can be arithmetic operations, logical operations, whatever they are. If you're just doing operations, you're not doing input or output, you're performing any other operation, that should be shown in rectangle. All right. And finally, diamond, and a diamond indicates a decision. So if this condition is true, then you take one branch, else you take another branch. You would have seen such examples in flowcharts. So far, all the examples that you worked out so far, if you convert them to flowcharts, you will not have a diamond in them. You will only have rectangles, parallelograms, and ovals. Now we will be looking at problems where a decision making needs to be done. Okay, you need to make a decision and take one branch or the other. So it looks somewhat like this, quite simple. So if some condition is true, you execute the statements in block 1. If it is false, you execute the statements in block 2. But both cannot be executed at the same time. Right? So if this is true. If the condition is true, you execute statements in block 1, else you execute statements in block 2. So this is a tree. This is a kind of a tree or a graph if you consider this below this thing also. But whether it's a tree or a graph, you can't put the tree or graph as it is in the program, right? You have to sort of linearize it. So you choose which block to write first. Either you can first choose to write block 1 and then block 2, or you can also choose to first write block 2 and then block 1. We will see both the examples now. Okay. So suppose, so the blue ones, block 1 comes first and then block 2. So it looks somewhat like this. So we write if condition. We need not write if condition is true. The moment we write if condition, it will enter that block only if this condition is true. Okay. So if condition, then you write block 1 statements. Okay. Else, which means if the condition is not true, then it will enter the else block. Okay. So you need not again write if condition is true. This is not necessary. Only if the condition is true, it will enter the if block. Else, it will enter the else block. Okay. Now suppose I want to write block 2 first. Then how should I modify my code? So how do I write opposite of condition? No, just condition. You just take any condition, right? Not only A greater than B, B greater than A. In this case, how do I represent it? Sorry? Block 2 and block 1. Block 2 inside? Block 2 inside block 1. Yes, so you're saying I should write block 2 here. But this condition also should change, no? Yeah. Exactly. So if I want to check if the condition is false, then you execute block 2. So I want to check that. So if I want to say if the condition is false, another way of saying it is if not condition is true. If will always overall it will enter only if it is true. Okay. So if you want the condition to be false and then enter, and that to be in the if block, so you consider the case of not condition being true. Okay. So you modify your code as if not condition. Then what will come here? Block 2. Else block 1. Okay. So there are two things you need to notice here. Only one of these branches will be executed at any point of time. If it enters block 1, it will not enter block 2, and vice versa. If it enters block 2, it will not enter block 1. Okay. That is one thing. Another thing is only in if there is a condition and then block of statements. In else there is no condition, because whatever are the remaining cases, you will enter else. Okay. In else you need not check for any condition. You will enter else only if all the previous conditions are false. So let's look at an example. Suppose if I want to check if a number is greater than 20, okay. First I scan the number. You see, I told you one tip last time. When you write your code, make it neat. That is indent. When you start a block, indent the code. Move it from the margin a little right. Second tip is add comments wherever necessary to make your code more understandable. Right? Because even when you get back to your code after a couple of months or even after a couple of weeks, you may not understand what your code is doing. So it's always good first to have a top line which explains what the code is doing at an overall level. So basically this code we can write this code checks if a number is greater than 20. Fine. This is the overall comment which explains what the code is doing, and then in between, once your code becomes long, you will need to add comments in between before a function or before a block of code to say what this block is doing. That will help you and also anyone else who is reading your code to understand what that code is doing. Okay. So scan the input from the user, and then if, what should I write? If n is greater than 20, I'll just say print. I don't want to say n is greater than 20. I want to say that value is greater than 20. Percentage d is greater than 20. Okay. New line. N. All right. That's all. Right now, I'm not worried about the else condition. Else is optional. Okay. So let's execute this. Some number 50. Yes, 50 is greater than 20. Maybe some other number 34. Yes, that is greater than 20. Let me give a small number 9. It's not doing anything because I didn't tell it what to do when the condition is false. Now I'll tell it else case. Else, no need of writing any condition. Just start the block. Else, I'll copy it. Printf percentage d is not greater than 20. Okay. Again, 45 is greater than 20. 9 is not greater than 20. That's it. Fine, simple. Now let's take another scenario. So let me copy this. Now, I want to write a code which gives, say, a grade letter to students based on their marks. Suppose I say above 80 is A, above 60 is B, above 40 is C. Just like that. Okay, this code assigns grades to students based on their marks. So I scan the input from the user, and depending on the number, it should tell me what grade the student will get. Fine. So scan done. If n greater than 80, printf. I'll just say A. Okay. Now there are three cases. What should I do? 80, 60, 40. There is something called else if. Okay. Else if n greater than 60 and less than 80. Okay, that's fine. So I will explain. Right now we will leave it like this. Even this will work. I'll explain why it works. Printf b, and then else if n greater than 40, printf c. Fine. Else print f fail. Okay. I can even add one more, say d in between. If it is greater than 20, print d, else fail. Fine. Let me say 35. 35 comes between 20 and 40. D. Okay. Let's say 70 would be B. Okay. 90 A. 10 F. Fine. Simple. Now, so let's keep it like this. Let me copy it and modify the other code. Yeah.
The user can enter the value above 100.
Then we will say what we will say. So if we say if n is greater than 80 and n less than 100, or what we will do, we will not worry about that. First, we will check if n is greater than 100 or n less than 0. Then we will say enter the correct value. And then we will check. Then we will understand that user is entering correct values, and then we will check this code. So what we will do, if n less than 0 or n greater than 100, printf incorrect value entered, please enter a value between 0 and 100. So another habit is whenever you put an opening bracket for a block, immediately first put the closing bracket and then enter the block statements. Okay. Otherwise, if you first put the opening bracket and then enter the block, inside the block, if there are again opening and closing brackets, you will get confused. You may forget putting the closing bracket of the original block. Okay. So whenever you are opening a bracket, immediately close it. Always put the pair of brackets together and then enter the content inside. And another thing, put the opening bracket in the same line instead of the next line. Like you can write this like this also, but it is a good habit to write it in the same line, opening bracket in the same line. I'll tell you why later. Right now, just remember that. Put the opening bracket in the same line, be it if condition or for loop or int main. You see always int main, I put the opening bracket immediately after the main in the same line. So these things just they are good habits, and there are some reasons for them, particularly this opening bracket in the same line thing. Okay. So we are assuming user will enter the correct value. Okay. Now, instead of else if, I will just use if conditions. Okay. The last one will be an else condition. Can you tell me what will happen? It will print all ABCD depending on what value we enter. Suppose if I enter 100, it will print all ABCD. If I print 45, it will print C and CD, only C, only CD, not F. Okay, so whichever number I enter, whatever is the top grade, from that grade it will print all the below grades except F, because I said else, right? So let's see. Suppose I say 50, it is printing both C and D, whereas the student should get only C, right? If I say 100, it's printing all ABCD. If I print 120, it says incorrect value entered, and then again it is checking the remaining conditions also. Okay, so that is why we need to put else if in all these cases. Okay, so I will not change this code. I will first, let me go to the previous code. Here I'll add else if. So the previous code is the correct code, whatever we want. If it is below 0 or greater than 100, you print enter the correct value. Else, if it is greater than 80, it means it is between 0 and 100. Because the previous condition is false, only then it will come here. And if even this condition is false, then it goes to the next one, which means it is less than 80. Okay. And it is greater than 60. Okay. If this condition is also false, which means it is less than 60, only then it will come to the next condition, which means it is between 40 and 60. If that 40 condition is also false, only then it will go to the next one, which means it is between 20 and 40. If the 20 condition is also false, it means it is between 0 and 20. So all the conditions are covered. Okay. So now you need not specially write if it is between 20 and 40, if it is between 40 and 60, if it is between 60 and 80, the else if is handling that. But if you don't use else if, then what do you need to do? In your if condition, you have to specifically mention if it is between 20 and 40. Again, if it is between 40 and 60, if it is between 60 and 80. Here you need not write else if. Okay, so else if means only if the previous conditions are false, only then it will enter else if or else. If means even if the previous condition is true, it will still enter this if also. They are independent ifs. Yeah. So you tell me. No. See, I said if n is greater than 40, print C. Else if n is greater than 20, print D. So if I get 20 to 40, it will print D. Only if I get 41, it will print C. If I want 40 also to be included, what should I do? Greater than or equal to. In each of these cases, I modify it to greater than or equal to. That's it. Okay, fine. Now, so these ifs, I need to modify saying if n is greater than 80 and n less than not or sorry, not this n less than or equal to 100, print A. Similarly, if n is greater than 60 and n less than or equal to 80, print B. And so here I'll modify it to 60, here I'll modify it to 40. Okay. Yeah. Now it will not print multiple grade letters. It will print only the correct grade letter. Which one is this? Third one. Say 40. It's printing only one grade letter. Say 30. One grade letter. 50. Now why is it printing F? Because this else is matching only with this last if. It is not matching with the previous ifs. Right? So here you again have to specifically mention again that if n less than or equal to 20, print F. Okay. If you want the last else to be linked with the first if and a chain of ifs in between, you have to put a chain of else ifs. You can't put a chain of ifs. If you put a chain of ifs, the last else will be linked only with the last if. Okay. If you want all of them to be linked, they have to be linked with else if. Okay. So I hope now you got an idea. If is compulsory, else is optional, else if is also optional, but you can have only one if and one else. In between, you can have any number of else ifs. Okay. Simple. And difference between if and else if is independent. Even if the previous if conditions are true or false, it will enter this current if condition. But else if means it will enter this else if condition only if the previous conditions are all false. All right. Yeah. Now let me modify this also slightly. Suppose I say if n greater than 20, print F. If it is greater than 40, print, sorry, if n less than 20, print F. If n greater than 20, print D. So let me remove this. $40, $60, $80. Okay. So 40, 60, 80, C, D, A. Okay. Now suppose if I enter 50, what will happen? Huh? What all will it print? It will print D, it will print C. Because it's greater than 20 also, it's greater than 40 also, right? Sorry? Second statement will be wrong. Why? N is greater than 20, 50 is greater than 20, right? So it will print D. Next, if 50 is greater than 40, that is also true. So it will print C, right? So let's check. D and C, right? Suppose I say 100 DCBA, all these it will print, right? So again, same issue. You need to understand how your statements are linked with each other. All right. So when I said it will enter only one branch and not the other branch, that is true only if they are if and else or if and else if. But if they are if and if, they are not two different branches. They are like one after another, like one block, then next block, then next block. They are not exclusive. Only when there is an if and else or if and else if, then they are exclusive, or else if and else, then they are exclusive. Okay, fine. So you can play with them any way you want. All right. Now let's look at another. So let me say, but I'll not get into the details of what issue it has. Okay. Now, let me copy. So we already saw this example once. Suppose if there are two numbers, I want to find which of them is greater. Whatever is the greater number, I'll just print its value. Okay. So I scan two numbers, A, B. And if A is greater than B, I say A is the highest number. If B is greater than A, I'll say B is the highest number. Else, both are equal. Okay. So how should I write it? If, what should I write inside? If A greater than B, close, then printf. I want to print the value. Okay. Percentage D is the greatest number. That is A. Then what should I write? Huh? Else if B greater than A, this will be B, and then else both are equal. Okay, that's it. Suppose I say 50, 20, 50 is the greatest number, 20, 50, 50 is the greatest number, minus 10, minus 20, minus 10 is the greatest number, 5 and 5, both are equal. That's it, right? Now let us consider the case of three variables, A, B, C. Now out of these three numbers, I want to find the greatest number. What should I do? So let's write the pseudocode. You see, when you have slightly complex problems, first write the pseudocode so that you separate logic and you separate syntax. You see, when you start typing immediately, your mind is struggling between both logic and syntax. So don't put so much burden on your mind. Separate logic. Just focus on the pseudocode. Once your pseudocode is clear, just translate it into your program. That's one of the most important habits, good habits, which a programmer should have. And a good programmer is one who writes the code just one time and it runs perfectly. That's it. It's not like you code something, you got an error, again go back, correct it, again run, again error, again correct. That's a very bad way of doing things. So whatever corrections you want to make, you make in the pseudocode. You should put it on pen and paper. Whatever corrections you want to make, that corrections, all those corrections should be made on paper. Done. Once you put it on computer, you should run the first time. That's how you should code. Okay. All right. So now, so first I read ABC. Then what should I do? If A greater than B, and or and, right? So when you're writing pseudocode, don't worry about the exact symbols. Is it ampersand or is it bar? It's just the logic that you're writing. If A greater than B and A greater than C, then yeah, print A is the greatest. Then yeah, else if B greater than A and B greater than C, print B is the greatest. Then else or else if? Else if C greater than A and C greater than B, print C is the greatest. Then else what will be the case?
A, B can be equal and C can be equal.
Yeah, it's not necessary that all are equal. Only two of them can be equal or all three can be equal. Okay, then you need to check first.
A is double equal.
Should you first check? Okay, let's say if A equal to B,
And A greater than C.
okay, and A greater than C,
A and B are greatest and A and B are greater than C.
okay, print A and B are the greatest. Okay,
Similarly, B, C and
else if B is equal to C and B greater than A, B and C are the greatest, then else if C equal to A and C greater than B, A and C are the greatest, then else are all are equal.
have opposite cases.
Else all are equal.
Sir,
Did we cover all the cases?
no, sir. Even they can be less.
Yeah. What about that case? A equal to B and A less than C. Then C is greatest. Right? So all these things are there, right? Yeah. So let's not worry about these cases for now. It will get too complicated. What we will do here itself, we will add greater than or equal to. Okay, if A is greater than or equal to B and A is greater than or equal to C. Similarly, else if B is greater than or equal to A and B is greater than or equal to C and this and this. So what we will print, we will not print ABC, we will print the value. This value is the highest. Okay, A's value or whatever. When I mean A, it is the value. Okay, so in that case, I need not worry about that. I only need to worry about two other cases. Even this I don't need. I only need to worry about the case where all three of them are equal, or that's it. Yeah, I only need to worry about the case when all three of them are equal. Do I also need to worry about the case when two are equal and less than the other? We are already covering them, isn't it? If A is greater than or equal to B, and if they are greater than C, you are anyway getting the value of A is greater than C, right? But you're not checking if all three are equal. Okay, so only condition which you need to check is else if, just to be on the safe side, specify that condition clearly. It may also be the case where that is the only remaining condition, but if you don't want to take a risk, specify that condition clearly, because else is anyway optional. All right, so else if A is double equal to B, you cannot write A is double equal to B, B is double equal to C like this. You have to write it separately. Okay, A is equal to B and B is equal to C. Then say print all are equal. Okay, so let's quickly test this. So, all right, yeah. Okay. Okay, so I'll say ABC, and actually I will not print immediately. I will just take a variable called max. I will assign the max value to this variable. So after all the if else blocks are done, finally I will print the max value is so and so. That's it. Okay. So scan one more. All right. Yeah, I don't know why again people started chatting. Okay, so if A greater than or equal to B and A greater than or equal to C, what I will do, I'll just say max equal to what is the maximum number? A. So else if B greater than or equal to A and B greater than or equal to C, then max equal to B. Else if C greater than or equal to A and C greater than or equal to B, then max equal to C. Then else if A equal to B and B equal to C, so what I will do, if we print the statement, then what will happen? Printf all are equal, and then suppose if I write printf the max or the greatest number is max. Now what will happen? It will print all are equal, and then it will also print the greatest number is both. It will print. I don't want both. So what should I do? First printf. Sorry, this one. I should put it above. Yes, that's a good point. Here you are saying I should write else. No. You see, this printf is printing the value of max. This max value can come from any of the previous blocks. If it enters any of the previous blocks, if I put an else and then printf statement inside that last else, it will not enter this else block, so it will not print. So this last printf statement is not in contradiction to the previous if else statements. Okay, so it will enter one of the previous if else statements, then it should come out of all the blocks, and whatever is the max value that should be printed. All right, so convert the last else if statement to if statement, how does it matter? This will also be printed. This will also be printed.
No, sir. Consider that if statement as a primary statement.
Okay.
Then rest of them being maps.
So this I should make else if.
Yes, sir.
Okay.
First we check for equality, if it is, then all else.
But again, it will print this statement also, no? That's what he said. If you put this print in else, this is what you're saying, right? Huh? Huh? Okay. But okay, right. That can be one option. Right. So that this printf will be linked only with this if condition. Okay. Yeah. Yeah, seems fine. Yes. Everyone understood? If they are all equal, it will just print all are equal. If any other case, if 2 are equal or 3 are different, then it will just print the max value. Fine? Good. Okay, so let's see. I give 3, 4, 5. Greatest number is 5. I give 3, 5, 5. Greatest number is 5. I give 5, 3, 5. I give 5, 3, 3. Greatest number is 5. I give all equal. All are equal. That's it. Fine. All right. Now the same code, I want to write it slightly differently. So what I'll do, I'll say if A greater than or equal to B, then inside this I will check. What should I check first? If A is greater than or equal to C, if this is the case, what should I do? Print, or I'll say max equal to A. Okay, don't worry about bracket right now because there is only one statement, max equal to A. Then else, what does it mean? This else is with this if or this if, inner if. Okay, if I'm entering this else, what does it mean? This is false. If this is false, what does it mean? C is greater than A or greater than A. Okay, if C is greater than A and A is greater than B, then max is C. Okay, yeah. So let's close this here. Now, if B is greater than or equal to C, or not if, I should say else, and then I'm also saying if B is greater than or equal to C. Okay, then what should I check for? You see, it will enter here only if B is greater than A, because this is else if, it is covering both conditions together. It is else if means this condition should be false, which means B is greater than A. If means this condition should be true, which means B is greater than or equal to C, which means B is greater than A and B is greater than or equal to C, which means max is B. What else? Suppose I say else. Else max is C. You see what all cases we covered? We covered the case where A is greater than B and here A is greater than C. And this condition says C is greater than A and A is greater than B. So this says C greater than A and A is greater than B. Okay. Now here, what did we cover? B is greater than A and B is greater than C. Did we cover all the cases? Really? Equal to, let's assume these are all equal to, greater than equal to. Did we cover all cases? Yes? No? We didn't cover all cases. What is the case that we didn't cover? C greater than or equal to? Did we cover the case where C greater than B greater than A? We didn't cover. So we should cover that case, right? So this will check that. So what does it mean? This means when I say else, it means C is greater than B. Okay. And since this is also not true, it means B is greater than A. That's it. So max equal to C. That's it. So only if all the previous cases fail, then it will come to this else. This failed means B is greater than A. This failed means C is greater than B. So combine both. B is greater than A and C is greater than B. So C is the max. Got it? So let's write this. So now I have the pseudocode. All I need to do is to translate it into program. I should, whatever changes you want to make, you should make it here. No changes, just translate it. The code should run. That's it. Okay. So this is nested if else. The previous one is like else if chain. If, else if, else if, else if, else. This is like nested if else. If inside that there is an if else, inside that there is an if else, again there is an else if, again there is an else, that kind of thing. Okay. So the previous one. Okay. Yeah. So let me remove all this. If A greater than or equal to B, if A greater than or equal to C, then max equal to A, right? Else max equal to C. Just copy the code as it is. Else if B greater than or equal to C, max equal to B. Else max equal to C. Now, if you notice, I didn't put brackets around this block, around this block, around this block, around this block. I have put brackets only around this block. Why? Only one statement. So if you have only one statement in a block, brackets are optional. If you have more than one statement, you should put brackets. Okay, in the previous course, even if there is one statement, I have put brackets because that's the beginning for you to know. Now, once you get used to it, if there is one statement, need not put brackets. Okay, so let's see. This will work. What happened? I didn't use max. Okay, I ran. Why is it saying I didn't use max? Okay, yes, thank you. Okay. In this case, we didn't consider all are equal scenario. Let's not worry about that. But greatest number is 5. Okay, it's working. That's it. So this is nested if else. Fine. So you can play with it any way you want, right? So whatever you're putting inside if, the condition which you are writing inside if, that is an expression. So that expression will have a value. When we say is a greater than 20, so a greater than 20 has a value. If it is true, it will be 1. If it is false, it will be 0. So if it is 1, it will enter that block. If it is false, it will enter other block. Right? That's all. Simple. So far, it's easy, clear. Okay. So yeah, just one more small thing. Suppose if I want to take a character and I want the user to tell me whether this character is a lowercase letter or an uppercase letter or a digit or okay, 3 girls get out, that pink dress, and the next 2 girls get out. Quickly get out. Earlier also I was seeing, and still you are doing the same thing. Get out. Okay, so suppose if I read some character and I want to see if the character is between small a and small z. Okay, print lowercase l. Else if the character is between capital A and capital Z, print uppercase. Else if the character is between digit 0 and 9, print digit. Else, if it doesn't fall in any of these above cases, print, say it's a special character. It can be a punctuation mark or whatever. Okay. So this I want to capture. So first I declare a char. Let's call it C or CH. It doesn't matter. I scan this character. What should I write? Percentage C. I'm scanning this as a character. I can also give its ASCII value. Both are same. If I am giving the character as character, I should write percentage C. But if I am giving the ASCII value of the character, what should I write? Percentage D. Okay. So if I am scanning it as a character, if you write 0 or 9 or whatever, if you enter 0, 1, 2, 3, any of these digits, they are treated as characters. So it will not store 0 as 0. It will convert it will find its ASCII value and store that ASCII value for 0 character. Okay. So percentage C ampersand CH. Now I need to check if CH falls between small a and small z. How should I write that? ASCII values. Okay. That can be one way. So what should I write? If CH less than or equal to, what is the ASCII value of small a? 97. What is the ASCII value of small z? 97 plus 25. 122. So I should say if CH is greater than or equal to 97 and CH is less than or equal to 122, print L. Okay, this is one way of doing it. I'll tell you a simpler way. I already told you, many times I told you percentage C, percentage D, percentage F, not F, percentage D, percentage X, percentage O. These are just representations. Finally, what is it storing? Number only. Okay, so you can compare representations also. Finally, it will use numbers only. So instead of using decimal representation, I can use character representation itself to compare. So what I can say, if CH is greater than or equal to small a and CH is greater than or equal to small z, or less than or equal to small z. Same thing. Since you are saying it's a character, by putting it in single quotes, it will take its ASCII value and compare with the ASCII value itself. So both are equivalent statements. All right. So first, let me comment this, copy this, and say this. Okay. Now, else if CH is greater than or equal to, for uppercase, capital A and capital Z, and yeah, else if for numbers greater than or equal to 0 and 9. So is this correct? We need to put single quotes there is a difference between number 9 and character 9, number 0 and character 0. Okay. Else printf special. Okay. Suppose I say 5, it's a digit. Suppose I say capital T, it's an uppercase, small t, lowercase, some character, percentage, it's a special character, right? That's it. So characters, again and again, I repeatedly keep saying character is nothing but a 1-byte integer. That is the reason we discussed binary, decimal conversion, all these things, different data types, so that you understand this code. So when you look at this code, you don't get shocked or surprised. Okay, this is possible because it is finally converting it to decimal using its ASCII value, and decimal is being converted to binary. That is why those concepts were discussed. Why binary, decimal, all these concepts. You for you to understand data types. Okay, so don't think they are unrelated to the programming. All right, yeah. So if you enter double digit, it will just take the first character. So let's see, 83, it will just take 8. Suppose if I enter 8 and a character, it will still take 8. It will just say digit. Suppose if I enter character and a digit, it will take the first character. It's a capital uppercase. That's it. Okay. Yeah. So let's stop here. Again.